Cool. So for this week, we are going to go over equivocation in Casper in terms of how it works and what it looks like with the inside different protocols. So I will begin this. Equivocation is when a validator sends out two messages that has no references in their justification, meaning the data or the other messages we have to like the other validator's values aren't syncing up to where validator one says, hey, I'm going to send out a 2 when there's nothing backing it up from the other validator that justifies that. So it's essentially just bad actors just trying to destroy the protocol. Now, supposed to move this one up, might be. But a recap from last week, we went over the family of protocols, which share the same asynchronous Byzantine fault tolerance safety, which helps keep the network secured. And for all the protocols, they must have a message, which consists of values, validators, and a justification. And the justification is a set of messages, pretty much of the validator's current state. This can also be interpreted as a clock inside the asynchronous network. Now, in terms of an estimator, I don't really know, so I hope one day or probably later on in this meeting, either Dror or Isaac, even Tomislav can help go over estimators to help me understand that. But that could be at a later time.
For sure, man.
Sweet. So this is something that Isaac helped me understand yesterday, is that Casper is meant to be single-threaded, meaning that it all is supposed to link up as they all reach to a consensus without no equivocation, or meaning no cuttings of the string. So when a bad actor or whenever someone equivocates or try to break the rules, you're essentially breaking the thread and almost like creating a new one. So just like how the blockchain just all lines up as like one solid chain, same as the consensus protocol where they all line up in a single manner. And I have an example of what it will look like to help kind of drive the single-threaded point home. Equivocation fault, it's almost like the same thing of just regular equivocation, but equivocation fault is when a validator is producing a valid message that could not have been produced by a single execution of its protocol. And what Casper protocols it applies to, it pretty much applies to all of them because it's one of the basic safety nets that all the protocols needs to be able to justify being correct initially. Now, here's a simple example of what equivocation will look like in just a binary. So we start off with Tom. He looks at Santa, and also he looks at Obama. So even though he looks at himself, he says, all right, well, because of their weights of 6, it has a 0. And let's look at Obama. Obama says, all right, I see Tom's latest message. Also, I see myself, which is 0, and Santa. So I choose 0. Now, what's unique, what Alex did was, Alex says, hey, even though I'm a 1 and I see the message around me being 0, even though I have nothing to justify my answer, I'm just going to cut from being a 1 to a 0. Even though it's correct, Alex will equivocate because there's nothing that justifies this answer the correct way. And so Alex, by definition, will be slashed because Alex equivocated. And when I mean single-threaded earlier, so as all these are kind of linked together, Alex is the only one that isn't linked. So it kind of breaks the thread a little bit.
So hey, Jeremy, just to clarify, so you're saying that Alex is not referring back to her earlier estimate in this most recent estimate, right? It's not in the justification.
It's not in the justification at all.
Perfect.
So the paper calls it invalid message fault. So in equivocation, it's only when you're saying two separate things, right? So if you sending this message with the same justification, but the value you proposing is different, or if the value you're proposing is the same, but you're having two justifications that don't refer to each other.
Yeah, so that's satisfied here, right?
So here you have Alex that has a justification that only has is the empty set, or actually not the empty, like he's saying one previously, let's say.
Right.
And then he derives a 0 out of it. So that's like an invalid message fault, in the sense that based on his justification, he derived the wrong estimate. That estimate shouldn't be derived.
So, Dror, I think that's an important distinction. I'm glad we're talking about equivocation versus invalid message faults, but I think in this case it really is an equivocation.
Right. Okay. So maybe
there's no red line there.
Yeah, I think so.
Yeah. Wow, Zoom is like messing up on me. All right. So yeah, the dash line, it was just to show what it looks like because I had a lot of lines. So technically, this doesn't exist.
Yeah. Okay. Right. Roger that. So Alex has two blocks here, right? She has the first one where she estimated 1, and it has an empty justification. So I think all by itself, that's a perfectly valid block. Then Alex also has a second block where she estimated 0, and she cites those other 3 blocks. And by itself, that's also a perfectly valid block.
Oh, so that's not a line. Okay, sorry.
Right. Okay. We're on the same page now.
Yeah, to help John, so you don't have to say like, oh, where's that 0 coming from? So yeah, it technically don't exist. I should have clarified that. I'm sorry.
Okay, cool.
Wait, Dror, could you say a little bit more about the invalid message faults?
Yeah. So if you create a message with and the value you propose in that message is not the value that the estimator should have proposed based on your justification.
Yeah. Okay.
That should be invalid, right?
Okay.
Joshi, how do you mean in this case that this is for equivocation? Because if this one from Alex never sent to anyone, it doesn't matter, right?
Oh yeah, that's a really interesting point. So like, I guess there's
because this one is not in justification of a 0, right?
Right. At least Obama has. Oh no, that's not true. Yeah. Oh wow. So let me just say this, and then you guys tell me if it makes sense or if it seems right. I would almost capture this as like Alex has equivocated because she's made 2 different blocks and neither one of them had the other in the justification. But then it's a separate question of whether anyone else is able to detect that equivocation and slash her. And at the moment, it looks like no one has noticed that equivocation because actually no one has seen either of her blocks at this point.
Yeah, I would totally agree with that. We see it because we have the God's eye view of the DAG, but nobody else has seen it yet.
Yeah, so it's still an equivocation, but it's just not in like seen, right? So
yeah,
but maybe I'm missing something. If this one of Alex in justification of a 0, this next message of Alex, why is this a problem? Alex can say, okay, but this one is only have a weight of me, like a 3, and this other 0 has much more weight, so I'm deciding 0.
Right.
Yeah, that's the proper thing to do, and then that would be a solid red line, right? But I guess just for the sake of an interesting discussion, that's not what she did in this case.
Yeah. But if this is like a real line, this is also not a problem, right? Or it is? Because I'm imagining that this is one Alex just made up, and later in this next message it says, okay, 0 has more weight.
Yeah, if she actually included the earlier 1 in her justification, like with the solid red line there, then yeah, that's totally valid and seems like the smartest thing for a real validator to do. Is that what you're getting at? Yeah.
So I'm saying that in both cases, Alex is have a valid message. Or I'm missing something.
Yeah. The message is valid either way, but it's still an equivocation because it doesn't contain the previous message in the justification.
Yeah, I agree.
Oh, how do you mean? I mean, contains justification from Santa, from Tom, and from Obama.
Well, no, but doesn't contain her earlier message in the justification.
You mean this one?
Yeah, exactly, right.
But why this change things? This one.
Well, so that makes it satisfy the definition of an equivocation. Whereas if the 1 was included in the justification, it wouldn't be an equivocation.
Jeremy, do you want to show us that little snippet from the paper again that defines equivocation fault?
Yeah.
But I mean, this 1 is not justified by any other message.
Right. Well,
so it's valid message.
Yeah. It's justified by the Genesis, if you want to say that.
Yeah. Okay, so that is helpful, but I think maybe somewhere else in this paper there's a more precise definition.
Yeah, like a mathematical definition of equivocation.
So basically no one saw the 1 message as well, right?
Yeah, it looks like nobody has seen either of those messages.
Right. So yeah, technically that means...
Yeah, there we go.
Yeah, no, she wouldn't be slashed yet because no one's detected it.
Yeah.
So you're saying like once they do detect it, here, I'm just gonna share my whole entire desktop, make this easier.
So 16, 17, 18 are the relevant equate. Oh yeah.
Cool. Oh, sorry.
That's okay. Let me just look at that real quick so that we can have a shared understanding of what equivocation means. So, well, I guess 17 and 18 are really the important ones. 2 messages that he's talking about as M1 and M2 here they're equivocating, and he uses that like perpendicular symbol. So M1 and M2 are an equivocation if and only if they have the same sender. So that's true in this case. Both of those messages were sent by Alex. They're not exactly the same message. That's the M1 not equal to M2. That's also true. They have different estimates and they have different justifications. And now here's the important part. It's all important, but here's the like more interesting part. M1 is not in the justification of M2. So that's correct. Her first estimate of 1 is not in the justification of the later estimate of 0, and vice versa. M2 is not in the justification of M1, and that's also true here. So that later message is not in the justification of the earlier message. So to summarize all that, if any one...
But later message is in justification. This 1 is in justification of 0.
Okay, so maybe we're still not clear on the meaning of the dashed line. I think that's the...
Oh, no. I was thinking that you're talking about this case, with not with dash, with a real line. You're talking about dash line.
We were going back and forth. We were talking about different scenarios.
I think maybe we should just delete the dashed line.
Sure. All right. Fair enough.
There you go. Yeah, that's the case that we're talking about.
My question is, you said that if this is the real line, like the one is in justification of 0, why is this equivocating, Alex?
Oh, it's not. It's not. If the 1 was in the justification, it's neither an invalid message fault nor an equivocation.
So in both cases, it's a valid message.
Yes. Yeah. In both cases, it's a valid message, but because in this specific instance where it doesn't refer back to that earlier message, then it's an equivocation.
Okay, I'm still confused because this one is never seen by anyone. So
right.
But there's so Tomislav, I think we have to consider like there's two different things, right? They're seen by Alex at least, right? So let's say if Alex is trying to decide herself whether she's equivocated, she's seen both of those blocks, and so she knows that she has. Also, we as just third parties are looking into this thing, seeing them, and we know that she's equivocated. But I agree with you that Obama doesn't know that, and Santa doesn't know that, and Tom doesn't know that. Maybe in the future they will, but right now they don't know that yet.
Yeah.
So, I mean, if you want, Tom, we can like play this out a little bit to see what it'll look like. Just add a couple more lines to it.
Well, okay, you're saying that Alex will eventually send this one, and then it will be equivocating. Is that correct?
I mean, I took it as, I guess maybe we didn't ever totally clarify what these drawings mean. I sort of took it as once we write a block on there, or once we write a message on there, it means that they've sent it out to the whole rest of the network.
Yeah, it's floating around in cyberspace somewhere.
Right, whether it's gotten gossiped all the way through or it's stuck because a shark chewed through the transatlantic cable or something. That's who knows.
Okay.
So are we good on this?
Yeah, I'm fine.
Cool.
Because in a way, like, yeah, I did kind of just stop it like right when it happened. So I think, like, for instance, if we would have just played this out where Santa wanted to go next, and then he looks at Tom and Obama, and even like Alex, well, obviously it'll be overweighted by 0, but since Alex equivocated and put up a 1, it'll still be 0.
Yeah, draw one in there if you want to. That could be interesting.
Oh, yeah. Let's see here.
There must be a message from Alex that doesn't that will contain 1 and 0 in the next message.
Yeah. Put a line from both Alex's 1 and Alex's 0 to Santa's 0.
All right. That is annoying. And then we can put Obama in there as well.
Okay. Can't forget about Obama.
Never. All right, here we go.
Cool. So Santa's seen the whole DAG at that point then.
But here's the question. So will this equivocation still count, though, knowing that this has no justification? So we already got Tom, which is 0. We already have, our Santa already sees himself. Obama already sees himself, and he has a justification of Tom and Santa, meaning that he has safe or consistent safety, right? So this already is a 0. Now the issue is when it comes down to Alex, and assuming that this equivocation propagated through. So I think we're probably looking at two things. This is assuming that the equivocation has already been propagated through, so technically you'll see a 0, but it'll still be slashed because there's no justification on this. Now, assuming that Santa did this before Alex, that means he'll see a 1, which will still outweigh the 0.
Okay, so let's see here. So definitely Santa at this point knows that Alex has equivocated.
Yeah.
And can slash it. The question then is, once that being the case, since Santa has slashed Alex, how does he then calculate his estimate? In this case, it's clear because everybody's estimated 0, right? But like, does Alex get any vote in that, or?
No, it's just they avoid Alex.
Yeah, so Santa doesn't have like unilateral power to just slash Alex at this point, does he?
I think, I mean, he has power to, in this block that he's creating, say like, hey, everybody, just FYI, Alex equivocated and I can prove it. So as soon as you see this block, stop, you know, or you also will agree or something. I'm not sure that's a totally rigorous notion yet, but yeah, close.
Right. Yeah, okay. That seems reasonable.
And after that, should other validators just skip the messages from equivocating validator or included but not calculated?
Yeah, I think that's right. Somehow the weights get reapportioned based on like some parameters that are set up from the beginning. At least that's my understanding of it. Now, Alex's weight will like go down to 0, so essentially they're just not seeing her messages anymore.
And they're not included anymore in justification.
I don't see why. So I actually haven't read anything like this in the paper yet. So I'm kind of.
Are we talking about the slashing?
Yeah.
Yep.
The paper doesn't specify slashing.
So is that an RChain specific thing or is it a Casper thing?
So I believe it's kind of up to the implementation.
Okay.
So as long as you can detect equivocations, then you're fine.
Right.
So
yeah, because the paper, this CBC Casper paper doesn't even talk about validator rotation at all, right? Like there's just a fixed set of validators.
Oh
yeah, but that also has nothing to do with the consensus part, right? That's more about making it fair and making sure people don't become monopolies really quickly.
Well, I was thinking that like slashing someone is a special case of validator rotation, right? Because you're kicking that validator out of the validator set.
So validator rotation is more about, so people don't stay as validator indefinitely and just increase their stake by validating. And then so it's more a fair system that people can join as validators.
Yeah, and Joshi, I think slashing is a slightly subtly different thing than validator rotation too, because not only is that validator kind of kicked out of the network, but their weight is reapportioned to the other, their stake is reapportioned to the other validators in the network, as far as I understand.
Yeah, I think that whole explanation of why is true, but I was thinking of validator rotation meaning changing the validator set.
Yeah, changing the set, but not the weights of the current validators in the set.
So if we remove Alex from the set, though, that changes it.
If Alex is just thrown out, then that would be validator rotation. However, if in slashing Alex, that 3 is distributed amongst the other 3 validators in some specified way before any of this began, then it would be different than validator rotation.
Well, hold the phone. I'm not sure. What we're really picking at here is a definitional thing, right? The definition of validator rotation. And so I'm claiming that validator rotation means any time the validator set changes. And then what I heard you say was, if we do this thing where Alex is removed and also other stuff happens, that doesn't count.
Right. Yeah. Okay. Right. So if validator rotation is just that general like validator set changes, you don't even worry about the weights whatsoever, then yeah.
Yeah. Okay.
And when you say validator set changed, when validator are equivocated, it is still in a validator set, because I mean it becomes one of the like a faulty validator, but it's counted in this validator set, right? It's not like we are missing one validator and just continue.
Yeah, I think that's right though, because Joshi and I were looking at the new version of like integer consensus and binary consensus, and there was always this notion of only looking at the honest estimates that you see.
But for calculating safety, we must know number of faulty.
Right.
Or like the number of valid. Sorry?
So you just ignore them basically when you calculate the weights in this paper. So this paper doesn't discuss slashing, doesn't discuss the unbinding. So to avoid the long range attacks, right? You need to make sure people cannot unbound quickly.
But I mean, we are calculating weights Sorry.
So also validator rotation is not something discussed. So all these things are just kind of more the crypto economics and securing the consensus protocol from attacks, which is different than what these papers.
Right. Okay. So all the slashing and stuff. That's all RChain specific stuff. So
I mean, it's something that Vlad was figuring it out through research.
Okay, but it's not part of CBC Casper. That's what I'm trying to do.
Yeah, exactly.
So Dror, then what I'm hearing you say, which makes a lot of sense, is in this scenario that we have on Jeremy's slide, moving forward, there's no like erasing Alex from the validator set or anything like that. She's still always going to be around. But from now on, when Santa is calculating his estimates, he's not considering anything that Alex says because he knows that she's dishonest. So he's just totally ignoring her.
Yeah.
Okay, that makes sense. And then later, as the game propagates, as Tom and Obama also learn that Alex equivocated, they'll start to do likewise.
Yeah, I mean, it makes sense also because probably to keep the math simple, because those things are kind of, non-important for this kind of proofs and can be left for the implementation. So probably it's not part of the CBC Casper part.
A curious question, let's just say hypothetically speaking that we do consider slashing. So even though like Alex is now gone and out of the picture, does her actions remain in the justification like as like more people being added to the network and Tom is like going down and like going to consensus, they still see Alex from like way back when. So if she ever does try to like sneak her way back in and say, hey, I want to come back in, they can say, well, no, because of this instance that happened in like Genesis.
Yeah, I'm not really sure how the protocol goes there, but it kind of seems like you wouldn't be able to go back in time and like retroactively adjust your justifications because then you're building a completely different DAG.
Yeah, I agree. It didn't happen in this picture, but in theory, like maybe Obama could have based one of his estimates off of something Alex said back before he knew that she was dishonest. So I think those would have to stay around as part of the history probably.
Yeah, it's kind of like, honest till proven dishonest.
Yeah.
Oh, yeah, I like that.
and probably validator that accept messages from Alex as valid it also will be equivocated, because he doesn't recognize Alex as invalid. I mean, because in justification he knows that Alex is invalid validator.
You're saying in Santa's latest block?
Yeah.
Yeah. Okay.
If you know that Alex is invalid validator, you must convert that, or you will be slashed also.
Oh, interesting.
So, but we started flashing in CBC Casper, right? My next best guess was that Santa just calculated that estimate. In fact, we can look at the equation, but my hypothesis is that Santa calculates that estimate based on the 3 honest block messages that he's seen most recently.
Yeah, he just ignores the equivocating estimate.
So somewhere in here, I think it's lower than this, he does friendly binary consensus and he defines the estimator.
Oh no, are we going to get into this right now?
Oh no, we don't have to. No, I don't know.
Well, look, I say that because Joshy and I spent about an hour like going back and forth between definitions in this paper to figure out what a superscript meant.
Yeah,
just
but now we
just
know.
to realize it didn't have anything to do with what we looked up.
We have an obligation to share that information so that everybody else doesn't spend an hour.
Yeah, that's true. That is a great point.
Okay, go down one little tiny bit more than where.
Yeah, I think it came up in the integer consensus.
Oh, okay. Well, maybe it'll be easier. Here. That's what I wanted to see. Wait. I thought up above they said estimator of sigma equals. Yeah, okay. Argmax of score. Oh, there's no. Yeah.
No, there is. It's in the score definition. Sorry.
Oh, right. Okay, right. So in one of the few unnumbered equations under definition.
Can you zoom in a little bit?
416. Yeah.
Perfect.
Right. So definition 416, he's defining score, right? And the score function takes in some x and some sigma. And the sigma is all the messages you've seen so far. And the x is the estimate that you're trying to score. So like 0, for example. Santa's trying to see what's the score of 0 given all these blocks that I've seen so far. And he's going to sum over, there's that thing down below the sigma that says LEH, and the H means honest. So he's only summing over all the honest validators. Does that seem right, Isaac? Or anybody?
Mm-hmm. Yep.
Yes, the H is not hypotheses or propositions, but honest.
Yeah. Right. So he's summing over all the validators in the validator set where the message is the latest message seen from an honest, oh, does that mean the latest honest message?
Wait, side note, we have less than a minute. So
Oh,
once it ends, you want to just like hop back in immediately, or we can probably use Jim's room.
Yeah, you can use my room.
Yeah, we'll pop over to Jim's room.
All right, yeah, Jim, if you could like send the link again to your room on Discord, that'd be great.
Oh yeah, or even in the chat right now, we could copy it real quick.
Let's see.
Because this kind of goes into my next slide, which is going over equivocation, but using the integer consensus. Because I needed like help coming up with a good example, so it all ties everything in.
Yeah, cool.
Let's see here.